Everybody, so here is 811. So we're going into chapter 8. You're going to have 3 assignments this week. This is the first one. The next one is going to be on a worksheet that I'll upload, and I should get that online to you hopefully on Monday. All right, so the question is, how can I find the product? We're introducing factoring. Now, last week, Friday, you actually did do factoring by doing like reverse distribution, but there's more ways to factor. The thing is, CPM does a horrible job of doing the whole factoring with backwards distribution. So it kind of stinks. Okay, so we went and did a day of that, and you're gonna have another day of that later. All right, so if you have your ebook open and then you're also listening to me, that's gonna be super helpful through this whole process. I'm gonna basically go through all the questions that I need to go through. So in 8.1, for part A, write the area of the rectangle at the right, and I did that here. I have a picture of it. Remember that the product represents the area found by multiplying and then the sum. Okay, so here's the thing. Okay, if I want to find the area as a sum, we would just take all these and add them together, right? So if I'm looking at this, I would have an XY tile. And then how many Y's? 1, 2, 3. Ooh, I forgot. There's one more up here. My bad. I am not the best drawer of these diagrams, you guys. So it looks like there's 4 here, and then there's up 4. Good. So as far as Y's goes, this is a Y, these are Y's, so we go 1, 2, 3, 4 Y's. All right. Then we have, it looks like just 1x squared, right? And then it looks like I'm going to have 4 x's here, and then 2 there. So 4 plus 2 is 6. Plus, and then it looks like we have 8 units here. Okay, that equals. Then how long is this? So if this guy is Y, this would be a Y by a 1 here. So this would be your Y here. This would be an X there, which makes sense because this is X by X, right? And these are all 1s. And this is a 1, 1, 1, 1. So would it make sense that this side would be, sorry, this is X plus 1, 2, 3, 4 times X plus Y plus 2. All right. So I'm going to kind of take this over here. X plus 4. I'm sorry, my Y looked like a 4. Times X plus Y plus 2, right? Okay, let's distribute the X through. X times X, that's an X squared. X times Y, that's an XY. X times 2, that's a 2X. Okay, and then we'll take the 4 through. 4 times X is a 4X. I'm going to put a 4X under here because it's with the 2X. 4 times Y is a 4Y. I don't have anything with a Y. 4 times 2 is an 8. I don't have anything with an 8. So this would be an X squared plus an XY plus, it's a 6X plus a 4Y plus 8. Well, isn't that exactly what I had here? X squared, XY, 6X, 4Y, and 8. So this is our sum, and that's our product. So the sum of the area is the area of the inside. And the sum as a product would be the length times the width. All right, so that's what we did there. All right, so I get kind of crunched here. So that's all of 8.1. So use a generic rectangle to do so in B. So I'm going to actually flip this over. And this is 8.1B because I don't have to go back to this one. If I have 6x minus 1 times 3x plus 2. Now, I am totally fine with you taking the 6x through here, the 1 through here, and then going into combining. But if you had to make a rectangle, this could be a 6x minus 1, and this could be a 3x plus 2. And if you need to, you could put the 6x minus 1 here and the 3x plus 2 there. Because remember, this is a rectangle, so they should be the same. 3x times 6x is 18x squared. Negative 1 times 3x is a negative 3x. Negative 1 times 2 is a negative 2. 6x plus times 2, that's a 12x. So as a product, this would be this guy. It would be what? I would have 18x squared. And then plus 9x, because 12x minus 3x is 9x, and that's minus 2, right? So then if I want to check this up here. So 6x times 3 is 18x squared, which makes sense. That's here. 6x times 2, that's 12, which makes sense. That's there. Negative 1 times 3 is a negative 3x. Makes sense. That's here. Negative 1 times 2 is negative 2. And that combines to give me 9x. So that makes sense. All right. Like I said, I would rather you guys not use generic rectangles. But when we're going backwards, because that's what we're going to do next, in 8.2, the only thing I want to do is get a definition for factoring, which last week I did do as well. Okay, factoring is changing a sum to a product. Okay, so far we've been taking a product and changing it to a sum. Eventually we're going to take a sum and then change it back to a product, but that's what factoring is. You need to have that in there. All right, so because I kind of know where we're going and what you're going to need, I don't really care about 8-2. I'm going to be honest with you. 8-2 just gives you all of these polynomials, like 2x squared plus 7x plus 6. And what they're going to have you do, if you want to do this, you can grab the algebra tiles out of your ebook. And you can try to take 2x squared tiles and then 7x tiles and 6 unit tiles and try to form them into a square. Once you form them into a square like we did here, you're going to find the outside and the inside. I'm going to be honest with you, I don't really care about that. So 8-2 to me is not that important. But 8-3 is. And I apologize, I wanted to get 8-3 all on one. So this is what I had. So here's what we got here. So for 8-3, this is A, B, and then that's C. And you guys need to, you may have to pause this video, but you need to have these on there, okay? So I'll walk you through A, and then I'll kind of give you time to do B and then C. Again, you're probably not going to get time from me. You're just going to be asked to press pause, and I hope you do. All right. So 6x squared, something times something would give me 6x squared. Now here's the thing. Whatever goes on this side has to also help me get a 2x. So 6x squared would be a 2x and a 3x. So it makes sense that you should have a 2x here and then a 3x here. Because if I have a 2x here, 2x times 3x is 6x squared. If I have a 2x here, wouldn't I have a 2x there? 2x times something equals 2x. That'd be 1. Okay? So that's why you have to have the 2 here and not have a 3 here, because 3 doesn't help me get 2. If there's a 1 here, there's a 1 here. 1 times something is 5. That something is 5. If 5 is here, it's there. 5 times something is 15x. 5 times 3x. That totally makes sense, and this all works. So if I'm taking this as a product, we would have 3x plus 1 times 2x plus 5. That equals, we usually put the squared term first. That's a 6x squared. Then we'd add those together, plus 17x plus 5. There you go. All right. We'll look at B together as well. So in B, I got a negative 2y, a 5xy, a negative 6, and a 15. So again, for 5, this spot here, this times this has to give me 5xy. This has to give me a negative 2y. Well, the only thing that's going to help me get a 5xy and a 2y, I need a y here. So I would need a y there. All right, if I have a y here, what do I multiply a y by to get 5xy? That'd be a 5x. Okay, 5x times a y, 5xy. All right, so then I put a y here. What do I need to multiply a y by to get negative 2y? That'd be a negative 2. That makes sense. Negative 2's here, negative 2's there. What do I multiply negative 2 by to get negative 6? That's 3. That makes sense. So 3 goes down here. 3 times something is 15x. That's a 5x. Sorry. And I have a 5x there. So therefore, if I'm writing this as a product, I would take 5x minus 2 times a y plus 3. That should equal, now nothing gets combined here. That's a 5xy plus a 15x minus 2y minus 6. Kind of probably got off my edge there. I'm sorry, I got off my paper. All right, so what I want you guys to do is C, okay? I want you to think about what that is. I'm going to press pause here, and then we'll come back to you in just a second, all right? All right, guys, so for C, what I did is I had to think about 12x squared and a 9x. Something helps me get a 12x squared and a 9x. So that would be a 3x. So I put a 3x here and a 3x here. If I put a 3x here, I put a 4x there. All right? Because 3x times 4x is 12x squared. That makes sense. So if a 3x went here, I put a 3x there. 3x times negative 3 is negative 9. Negative 3 is here, negative 3 is here. Negative 3 times 4 is negative 12. 4 goes here, 4 goes here. 4 times 4x is 16x. Therefore, as a product, this would be 4x minus 3 times 3x plus 4 equals, all right, that'd be 12x squared, because we always want the square term first. Combining those, wouldn't that be what? 16 minus 9 is what, 7? Plus 7x minus 12, right? All right, so there you go. And so that would be that product. All right, last question of the day is question 4, which is super duper important. So in question 9-4, so this is basically looking at question number, or part A from 8-3. So what they did is they circled these two, right? Yep. And then these two. All right, so while working on problem 8-3, Casey noticed a pattern in the diagonals of each of the generic rectangles. So we'll actually look at the other ones and make sure this happens too. However, just before she shared her pattern with the rest of the class, she was called out. the drawing of on a paper showed this. What can you figure out is the relationship between the diagonals. So I want you guys to press pause. I want you to figure out what could be the relationship. If common ideas would be, could I add them, add, multiply, subtract, divide? What do you think? All right, guys, so I'm hoping that you added them, and 11, that you can't even add those together. But if I multiplied this, that's 30x squared. 15 times 2 is 30. X times x is x squared. They equal each other. So then I'd go back to the other ones and see if they also work. So I'm going to actually use a different color. That way you guys actually see me actually doing some work. So I apologize. This is just some, so I don't bleed straight through. So if I'm going to go with negative 9x times 16x, that's a negative 144x squared. This is for C. 12x squared times negative 12x, that's negative 144x squared. That equals, okay, A we did. B, if I take a negative 2y times a 15x, wouldn't that be negative 30xy, right? Sorry, I'm getting kind of off my paper. I'll go like that. Sorry about that. And if I take a negative 6 times a 5xy, wouldn't that be a negative 30xy? Those guys equal each other. Ooh, so we have something really good. All right, guys. So when I'm looking at this, the relationship, and this is super duper important, is that the product of the diagonals is the same. Super duper important. That is what she found. That is what is really important in all of this. All right? So the diagonals would have to be the same. Okay, which brings us to 8.5. Don't really worry about that. A quadratic expression. Quadratic expressions have x squareds in them. Other vocabulary you can put in there would be a quadratic expression. That's things that have x squareds in them. Factors. Factors are things that divide evenly into other things. A monomial is just a number, or it's going to be a variable, or it's going to be the product of numbers or variables. Binomials are two monomials that are added or subtracted. Trinomials are three of them, and they give examples in the methods and meanings, and I would take a look at that. So for your homework, the very first assignment of the week, you guys are going to look at questions 8.6 to 8.12. I know you don't have packets, therefore you're going to have to use your ebook. See, ebooks came in handy. Okay, good luck.